Hello my dear students, I warmly welcome you to CR Digital Classes. So in this lecture we are going to discuss about the third difference operator table, that is central difference operators. Okay, see the question first of all. Define central differences and explain the procedure to construct a central difference table. Okay, so in present days in the examination the questions also coming in this format only. They are not asking the problems, they are asking the explain the procedure for the method. Okay, so therefore you need to focus majorly on the based on this type of questions only. Let y is equal to f of x be a function, and y naught, y1, y2 up to so on y suffix n are the represents of the small y. Here small delta y suffix 1 by 2, small delta y suffix 3 by 2 up to so on small delta y suffix n minus 1 by 2 are called the first central difference operators. Okay, first central differences which are defined as small delta y 1 by 2 is equal to y1 minus y0, small delta y suffix 3 by 2 is equal to y2 minus y1 up to so on small delta y suffix n minus 2 is equal to y suffix n minus y suffix n minus 1. Okay, so therefore where delta small delta is called the central difference operator, where small delta is called the central difference operator of order 1. Next is second order central difference operator. Second order central difference operator is defined as del square y suffix n is equal to del y suffix n plus 2 minus del y suffix n minus 2. Okay, so this is the second order central difference operator formula. So similarly, nth order central difference operator can be defined as, so therefore del power y suffix r minus 1 by 2 is equal to del power n minus 1 into y suffix r minus del power n minus 1 into y suffix r minus 1, where small r starts with 1, 2 up to so on. Okay, so this equation deals with the whenever small n is odd integer. Okay, for small n odd value, so you have to use this formula. Whenever you take small n is an even value or even integer, you have to use this formula. Okay, delta power n y suffix r is equal to delta power n minus 1 into y suffix r plus 1 by 2 minus delta power n minus 1 into y suffix r 1 minus 1 2. Okay, so for r is equal to 1, 2 up to so on. So this total gives the central differences and central difference operators. So in the next page we can see that the central difference table. Here for the first two columns from the problem they will give clearly x naught values and corresponding values of the y's. So now by taking the subtraction value of y1 minus y0, you can write first the central difference operator. Okay, this total row deals with first central difference operator, del y suffix 1 by 2, del y suffix 3 by 2 up to so on del y suffix 11 by 2. Okay, so next second central difference operator can be denoted as del square y suffix 1, del square y suffix 2, del square y suffix 3 up to so on del square y suffix 5. Here this del square y suffix y1 value we can get by subtracting these two values. That means clearly we can write del suffix y 3 by 2 minus del suffix y 1 by 2. Okay, that is the value. This total column represents the second central difference operator, that is denoted as small delta square. In the next to this total third column, we can denote it as third central difference operator, that is denoted by small delta cube. Okay, so here this delta cube y suffix 3 by 2 value we can write the subtraction value of these two values, that is equal to, you can write del square y suffix 2 minus del square y suffix 1. Now this total column represents the fourth central difference operator, that is denoted as small delta power 4. Now this first value we can write it as the subtraction of these two values, that is equal to delta power 3 y suffix 5 by 2 minus delta power 3 y suffix 3 by 2. Okay, so next this total column represents the fifth central difference operator, that is denoted by delta suffix 5. Okay, so this delta suffix 5 value gives the subtraction of these two values. Okay, so at the end of the table we can discuss the sixth central difference operator, that is denoted by delta power 6. Okay, so these powers of this central difference operator depending upon the initial values. Initial values is, if you end the initial value with x suffix 6, you will get the values up to delta power 6. Okay, if you end with x suffix 5, you will get up to delta power 5. Okay, if you end with x suffix 10, you will get the orders up to delta power 10. Okay, in the problems based on in this method, x0 and y0 values they will give in the table format. With the help of those values, we have to find out each and every value, delta y suffix 1 by 2 and up to so on delta y suffix 11 by 2. Up to we have to derive all these values. After deriving all these values, we have to substitute those values in the Gauss central difference polynomial. Okay, Gauss central difference polynomial. After deriving the values of the equation, then we have to find out the corresponding values of the y ordinates. Okay, so this is the general explanation of the central difference operator. So this central difference operator is denoted by small delta. In this method, so we are going to discussing different types of problems. Okay, so this is the total explanation of this problem. Okay, I hope you understood this problem very well. In the next lecture we are coming with another interesting method. Okay, make a perfect practice, prepare well. Until bye, thank you.